Hello, in this video, I'm going to discuss how to connect to EC2 using Instance Connect. This is part 3 of How Do I Connect to my EC2 series. In this video, I will start with a quick demonstration, then go through the steps to build a solution. I will conclude with pros and cons of using the Instance Connect solution and discuss some alternatives you may want to consider. One of the main advantages of using Instance Connect is that you don't need an SSH key to connect. Instead, it uses IAM permission to authenticate to EC2. If your EC2 is inside a private subnet, meaning it doesn't have a public IP address or access to the internet via the internet gateway, you can still connect using Instance Connect Endpoint. Keep in mind that the Instance Connect solutions I will discuss in this video only works for Linux EC2, not for Windows. So let's jump in. I'm on the AWS console, logged in as an IAM user named Stuzio Admin. On this EC2 page, I have a single EC2 instance launched called Demo Public Linux. This EC2 instance is in a public subnet. So in order to use Instance Connect, all I have to do is select the EC2, click on Connect. And here I'm on the EC2 Instance Connect page. I'll use Connect using a public IP address, and I simply click on this Connect button. And when I do this, a new tab gets launched, and now I'm connected to the EC2 using SSH. I can also connect to this EC2 instance using Instance Connect using AWS CLI. So here I have a terminal application launched. I already have AWS CLI installed. At this point, all I have to do is issue this command. In this command, I have to specify the instance ID, which I can get from the EC2 console page. And now I'm connected using the AWS CLI from my laptop. So using Instance Connect is very convenient and simple. And the main advantage of using Instance Connect is that you don't need an SSH key in order to connect, because it uses IAM credential. Here I have a diagram of the solution. I will explain each component and show you how to build this yourself. By the way, if you want to get this diagram and steps to build a solution, see the links in the description of this video. There are two use cases we will build using Instance Connect. First is connecting to a Linux EC2 inside a public subnet from the internet using either AWS console or AWS CLI. Second is connecting to Linux EC2 inside a private subnet using the Instance Connect Endpoint service. Let's start with the first use case, which is to connect to a Linux EC2 inside a public subnet from the internet. For this use case, we will use an IAM user named Brian, who will connect first using the EC2 console, then connect again using the AWS CLI from his laptop. Before I launch my Linux EC2 instance, I need to configure several networking components. So let's go over to the AWS console to build a solution. For this demonstration, I'm logged into the AWS console as an IAM user named Stuzio Admin. In the IAM user page, you can see that this user has administrator access permission, so I am able to create just about any resource in this account. So the first step is create the virtual private cloud VPC and the subnet. On my console, I'm on the VPC dashboard. I'll click on the Create VPC. I'll use the VPC only option. I'll name my VPC Demo VPC. For the CIDR, I will enter 10.0.0.0/16. I'll leave everything else as default and click on Create VPC. Before I move on, I'm going to enable the DNS hostname. Notice that currently the DNS hostname is disabled. So I'll go to Action, Edit VPC Settings, check the Enable DNS hostname. If you enable this setting, then your EC2 will get assigned a public DNS name that we can use to reference it from the internet, like a public IP address. Next, I'll create the subnet. Click Create Subnet, and I'll select my VPC. In this case, the demo VPC that I just created. I'll name this subnet Demo Public Subnet. I'll leave the availability zone as no preference because it doesn't matter for this demonstration. For the subnet CIDR block, I'll enter 10.0.0.0/24, which is a subset of the CIDR block of my VPC. I'll leave everything else default and click on Create Subnet. The next step is to create the Internet Gateway and the route table. The purpose of this component is to create a networking route so I can connect to the EC2 from the public internet. So I'll click on Internet Gateway, create Internet Gateway. I'll name my gateway Demo Internet Gateway. Notice that the state is currently detached, so I have to attach this to my VPC. I'll go to Attach to VPC and select my demo VPC and click on Attach Internet Gateway. The next thing I'll create is a route table. Just because we have the Internet Gateway doesn't mean any traffic will be routed to it. We need a route table that instructs the subnet what traffic should be routed to the Internet Gateway. So I'll click on Create Route Table, and I'll name this route table Demo Public Route Table. And for VPC again, I'll select the Demo VPC. Create Route Table. Notice that the route table has the default route for the local. We need to add a route for the Internet Gateway. I'll click on Edit Routes, Add Routes. For destination, I'll select 0/0, which is all Internet. For target, I'll select Internet Gateway and my Internet Gateway Demo Internet Gateway instance. Click on Save Changes. Okay, so now I have two routes on this route table. I now want to associate this route table to my subnet. I'll click on Subnet Association, Edit Subnet Association, click on my Demo Public Subnet. So now I have a route table associated with my subnet that instructs all destinations other than the local VPC CIDR should be routed to the Internet Gateway. The last step before launching my EC2 is to create a security group. Security group is a type of firewall that controls what type of inbound and outbound traffic will be allowed for my EC2. For the first method of connecting from the EC2 console, I will need an inbound rule that allows SSH traffic on port 22 from the Instance Connect service. So here I am on the VPC console. I'll click on Security Group, Create Security Group. I'll name the security group Demo Instance Connect Security Group. For VPC, I'll select Demo VPC. I don't need an outbound rule, so I'll delete this. For the inbound rule, I'm going to select SSH type. Notice that when I select SSH, the protocol and port range is already selected. For the source, I will need to specify the Instance Connect service. The way I'm going to do this is by using the prefix. So if I scroll down here, I'll see a list of prefixes that are available for me to use. I'll select my region's Instance Connect prefix list. This is a list of public IP addresses that's managed by AWS for each region. Notice that I didn't select the IP address of my laptop. Instead, I selected the prefix list for the EC2 Instance Connect service. Okay, with that, I'll create security group. Now that we have all the networking pieces in place, we are ready to launch our Linux EC2. This is going to be inside our demo public subnet using the Demo Instance Connect security group we just created. So here I'm back on AWS console on EC2 service page. I'll click on Launch Instance. I'll name this instance Demo Public Linux. For application OS image, I'm going to select Amazon Linux and select the Amazon Linux 2023 AMI. So AMI stands for Amazon Machine Image, which is an image that provides the software needed to boot an Amazon EC2 instance. The image you choose here is important because in order for Instance Connect to work, it needs a software called EC2 Instance Connect running on it. By selecting the Amazon Linux 2023 AMI, I know that EC2 Instance Connect is already installed on my EC2. If your server does not have the EC2 Instance Connect installed, then you must first install it. You can find a list of AMIs with EC2 Instance Connect pre-installed and other prerequisites in the EC2 Instance Connect documentation. For instance type, I'll leave it as T2 micro. And for key pair, I'm going to proceed without key pair. Essentially, I do not need a key pair in order to connect using Instance Connect. This is one of the main advantages of using Instance Connect. For networking, I'll select Edit. For VPC, I'll select the Demo VPC. For subnet, I'll select the Demo Public Subnet. For auto-assign public IP, I'm going to enable this. By enabling this, I will get a public IP assigned when this EC2 launches. This is required for this use case. For a firewall, I'll select Existing Security Group and select the Demo Instance Connect Security Group. This is one we created earlier. And that's all the settings that I need, so I'll click on Launch Instance. Let's go check it out. It'll take a few minutes for a status check to complete. If I look at the summary, I now have a public IP address as well as public DNS, and this is running inside a demo public subnet. Let's try to connect to this EC2 using Instance Connect. Currently, I'm still logged in as Stuzio IAM User who has administrator access permission. So I'll click on Connect. And in the Instance Connect, I'll use the Connect using public IP address. And notice that the username EC2-user is already selected. And I'll simply click on Connect. And within my browser, I am now connected to my EC2 instance. And when I'm done, I can click Exit. If you recall our original use case, what we want is an IAM user named Brian to connect to this EC2 instance using Instance Connect. So let's try that. If I look at Brian, the IAM user, currently he does not have any permissions. So let's log in as Brian and see what happens. I'll use the handy multi-session feature and I'll log in as Brian in this browser. Okay, now I'm on the console as an IAM user named Brian. I'll go to the EC2. If I look at the instances, notice that I don't see any instance in this region. That's because the IAM user Brian does not have any permission, so I cannot connect to this instance. So the question is, what is the minimum amount of permission that Brian needs in order to connect to an EC2 instance using Instance Connect? So let's go back to the IAM user. And again, now I'm back logged in as Stuzio admin looking at Brian's permission. And I'll add a permission. I'll attach policy directly. And I'll select a customer managed policy named Demo Instance Connect Policy. This is simply a custom managed policy that I created with certain permissions that I need in order to connect to EC2 instance using Instance Connect. So I'll click Next, Add Permission. So now if I look at this permission called Demo Instance Connect Policy, let's look and see what's inside. You can see this statement that contains 3 actions that are allowed on all resources. These are the minimum actions that are required in order to connect to EC2 using Instance Connect. You can enhance this statement if you want to by adding certain conditions that limit which resource that this principal is able to connect to. But for this demo, I don't have any conditions. Therefore, this IAM user Brian is allowed to take these actions on all resources. So now with this permission, let's go back to the console as Brian. If I refresh this page now, I will see my demo public Linux instance. When I select on it, I still get lots of failed messages because I have very limited permissions attached to this IAM user. But at least I should be able to connect. So I'll click on Connect. Here I'm on the EC2 Instance Connect. Notice that the username this time is default to root. I can change this to EC2_user. Or you can use the root user if you want. I'll click on Connect. And so now with this permission, IAM user named Brian is able to connect to this EC2 instance using Instance Connect. Now let's enhance this solution to allow Brian to connect using AWS CLI from his laptop rather than using the AWS console. So I'll launch the terminal application from my laptop. Note that on my machine, I already have AWS CLI installed. And if I look at my AWS credential file, notice that I have the access key and secret access key of Brian IAM user already entered. So when I issue AWS CLI command, I am using the IAM credential of the IAM user Brian. So now what I'm going to do is issue this command, which uses the EC2 Instance Connect to establish an SSH connection to my demo public Linux instance. Notice that this requires instance ID, which I can get from the instance summary page of my EC2. So let's try this. After a while, I get this error. The reason why I get this failed error is because in order for me to establish a connection from my laptop, I need to allow inbound SSH connection from my laptop. So let's go back to our console and modify this. I'm back on my VPC page in the Demo Instance Connect Security Group. And I'm going to edit inbound rule. Recall that we added this inbound rule for SSH in order to connect from the EC2 console using Instance Connect. Now we need to add another rule. Type will be SSH, but the source this time will be my IP. In other words, my public IP address of my laptop. Now, strictly speaking, the first SSH rule is only needed if you're going to connect from the console. So with that, I'll hit Save Rules. So now I have two inbound rules for this security group. Let's go back to the terminal. I'm going to try this command again. And this time, it succeeds. So the important thing to notice here is that in addition to the IAM permission that Brian needs, we need two different inbound rules for security group depending on how Brian connects. If you're going to connect only using the EC2 console, then you can use the prefix list for the Instance Connect service. But if you're going to connect using AWS CLI from your laptop, then you will need an inbound rule for the IP address of your laptop. The next use case is to use EC2 Instance Connect to connect to EC2 inside a private subnet. A private subnet here simply means the EC2 instances inside don't have a route to the internet. These may be your database or application servers that you don't want to expose to the internet. Recall in our previous use case, with a public subnet, the EC2 was assigned a public IP address and there was a route to the internet via the internet gateway. So if the EC2 inside a private subnet doesn't have a route to the internet, how can we connect to them from the internet? The answer is Instance Connect Endpoint. The way this works is that the EC2 Instance Connect service deploys an Elastic Network Interface, or ENI, into one of your subnet inside your VPC. Then, the Instance Connect uses this ENI to establish connection to your EC2 within a private subnet. So let's build a solution to see how this works. So the first thing I'll do is create a new private subnet and a route table to launch our EC2. Here I'm on the AWS console, again logged in as Stuzio admin. I'm going to reuse my demo VPC. So in order to create a subnet, I'll click on Subnet, Create Subnet. For VPC, I'll select Demo VPC. I'll name this subnet Demo Private Subnet. For availability zone, I'll leave it no preference. For subnet CIDR block, I'll select 10.0.1.0/24, which is a subset of my VPC CIDR block. I'll leave rest as default and create subnet. So next thing I'm going to do is create a new route table for this subnet. Click on Route Table, Create Route Table. I'll name this route table Demo Private Route Table. For VPC, I'll select Demo VPC, Create Route Table. Notice that it has a default route for the local. And this is all I want because this route table is going to be used for my private subnet. Next, I'll go to Subnet Association, Edit Subnet Association, and I'm going to associate this route table with my private subnet. Save Association. So now I have a private route table associated to my demo private subnet. The next thing I'm going to do is create two new security groups. First is Demo Instance Connect EC2 Security Group, which I will use to control traffic for my EC2. Next is called Demo Instance Connect Endpoint Security Group, which I will use to control traffic for the Elastic Network Interface the Instance Connect Endpoint will deploy. So I'm here back on AWS console, logged in as Stuzio admin. I'll click on Security Group, Create Security Group. I'll name this Demo Instance Connect Endpoint Security Group. For VPC, I'll select Demo VPC. For now, I'm going to delete this outbound rule and just save without any rules for now. We'll come back to this. Create Security Group. Let's create the second security group. Create Security Group again. I'll name this Demo Instance Connect EC2 Security Group. For VPC, I'll select Demo VPC. For the rules, I don't need any outbound rules, so I'll delete this. And I'll add an inbound rule. So this security group needs to allow SSH inbound traffic on port 22 from the Instance Connect Endpoint ENI. So for type, I'll select SSH. And for source, I'm going to specify the demo instance connect endpoint security group that we just created. Alternatively, you could specify endpoint ENI's private IP or CIDR block. With that, I'll create security group. Okay, let's go back to security group. Now let's configure the demo instance connect endpoint security group. Recall that this security group will be used to control traffic in and out of the instance connect endpoint ENI. So for this security group, I'll need to add an outbound rule. Edit outbound rule, add rule. So the type here will be SSH again. And for destination, again, I'm going to select the security group. This time, I'm going to select the Demo Instance Connect EC2 security group. Again, alternatively, you could specify the private IP address of the EC2 or the CIDR block. But at this point, we do not have the EC2 launched yet. So the convenient way is to specify the security group that you will be using for this EC2. With that, I'll save rule. At this point, you may be wondering, what about the inbound SSH traffic from the Instance Connect service to this endpoint ENI? Don't we need an inbound rule for that? Well, this route is open by default, so you don't have to create the rule for it. So now I have a security group for the endpoint ENI that allows outbound SSH traffic to EC2 security group, and another security group for the EC2 that allows inbound SSH traffic from the endpoint ENI. With these two security groups, we're now ready to deploy the Instance Connect endpoint. The next step is to deploy the Instance Connect endpoint, or in other words, the Elastic Network Interface, into one of our subnet to be used to connect to our EC2. So back on my AWS console, I'm on the VPC page. I'll click the endpoint, create endpoint. Here I'll name the endpoint Demo Instance Connect Endpoint. For the type, I'll select EC2 Instance Endpoint. For network setting, I'll select the Demo VPC. In the additional setting, there is an option to preserve client IP. If you select this, then there is some nuance on how to configure the security group. However, since in our security group, we use the security group as a source and destination reference, the endpoint will work regardless of whether you select this option or not. For now, I'll leave this option unchecked. For security group, I'm going to select the Demo Instance Connect Endpoint security group that we created earlier. This allows outbound SSH traffic from this ENI to our EC2 in private subnet. For the subnet, I'm going to select Demo Private Subnet, but it actually doesn't matter which subnet you choose. The rule is that you can only have one endpoint within a VPC, so effectively you can only choose one subnet. Again, in our security group, since we used security group as a reference for source and destination, it doesn't actually matter which subnet you choose here. However, if you use CIDR block or private IP address, then you have to make sure that the security group allows both inbound and outbound traffic from the subnet that you select here. So for this demo, I'll just select the Demo Private Subnet. And now I'll create the endpoint. This will take a few minutes for the status to complete, but we can see that this endpoint is in our Demo VPC, and it is associated with our Demo Instance Connect Endpoint security group. Now that the status is available and the endpoint is ready to be used. If I look at the subnet, you can see that this endpoint is in my Demo Private Subnet, and it has a private IP address from the subnet CIDR block. And you can even see the network interface ID. If I click on this link, you can see the details of Elastic Network Interface that was actually deployed. So now we're ready to use it. Now that we have all of our networking components configured, including Instance Connect Endpoint, we are now finally ready to launch our EC2. So back on my AWS console, I'm on my EC2 page. I'll click on Launch Instance. I'll name my instance Demo Private Linux. For application and OS image, I'll select Amazon Linux with Amazon Linux 2023 AMI. Again, by selecting this AMI, I know that Instance Connect software will be included. For instance type, I'll leave it as T2 Micro. And for key pair, I'm going to proceed without key pair. Recall that Instance Connect uses IAM permission when connecting using SSH. so I do not need a key pair for this purpose. For networking, I'll select Edit. For VPC, I'll select Demo VPC. For Subnet, I'm going to select Demo Private Subnet, and I'm going to leave Auto-Assign Public IP disabled. Recall that this EC2 instance is meant to be private without access to the internet, so I do not need a public IP address. For firewall or security group, I'm going to select Existing Security Group and select the Demo Instance Connect EC2 Security Group that we created earlier. And that's all the configuration, and I'll launch the instance. Let's go check it out. It'll take a few minutes to complete the status check, and now it's ready for use. Now that we have the Demo Private Linux EC2 launched, let's test connecting using Instance Connect Endpoint. So here I'm logged in as Stuzio admin. I have selected the Demo Private Linux EC2. I'll click on Connect. Here I'm on the EC2 Instance Connect. Since this EC2 does not have a public IP, I'm going to use Connect using private IP using VPC Endpoint. Notice that for the EC2 Instance Connect Endpoint, my Demo Instance Connect Endpoint is automatically selected. I'll leave my username as EC2 user and click on Connect. So now I'm able to connect to my Demo Private Linux from my console over the public internet using the Instance Connect Endpoint. Now let's go back and try this as Brian IAM User. Here on this tab, I'm logged in as Brian IAM User on the EC2 page. Recall that IAM User Brian has very limited permission. So let's try connecting to this Demo Private Linux as Brian. So again, I have Demo Private Linux selected. On the EC2 Instance Connect, I'll select Connect using private IP address. When I go to select the EC2 Instance Connect endpoint, now I get an error that Brian is not authorized to perform this action. So before Brian can connect using EC2 Instance endpoint, we have to modify his permission. So let's go back to modify Brian's IAM permission. Here I can see Brian's IAM permission. Currently, he has one permission policy, which is Demo Instance Connect policy. Recall that this policy was attached for the previous demo where Brian connected to an EC2 instance in a public subnet. Now, in order for Brian to connect to a private subnet using Instance Connect endpoint, we need to modify this policy. So I'll click on Edit Policy, and I'm going to add two new actions. The Describe Instance Connect Endpoints and Instance Connect Open Tunnel actions are required. So now I'll click Next, Save Changes. Let's refresh Brian's permission policies. Now the Demo Instance Connect policy attached to Brian has two additional actions. So now let's go back and try to connect as Brian. I'll go back to Instance and select Demo Private Linux again. Click on Connect. On the EC2 Instance Connect, I'll select Connect using private IP. And notice that now Brian is able to select the Instance Connect endpoint and click Connect. And now Brian is connected. Let's try to see if Brian can connect using the AWS CLI from his laptop over the internet to the Demo Private Linux. So I have the terminal application open. Again, I have the AWS CLI installed. And recall that I have Brian's credential already configured. So I'm going to use this command, AWS EC2 Instance Connect, in order to establish SSH connection. Notice that I have an instance ID parameter, which I can get from the AWS console for EC2. And for connection type, I have to specify EICE in order to specify that this is for the Instance Connect endpoint. So I'll issue this command, and connection is successful. So this demonstrates that Brian is able to connect both EC2 console as well as AWS CLI from the terminal application from his laptop to the Demo Private Linux, which is inside a private subnet without a public IP address or a route to the internet. So is EC2 Instance Connect the right solution for you? It certainly has its advantages, namely that you don't need an SSH key to authenticate. Instead, you can use IAM credentials. This may be a big advantage, especially if you're working in a large organization with hundreds of developers and thousands of EC2s, because you don't have to distribute lots of SSH keys. Instance Connect works for both public and private subnets, which is a bonus. It is a very convenient way to connect, especially for Linux EC2, right from your EC2 console. The downside is that you still need to open inbound port 22 for SSH for your EC2. This may be a security risk for highly sensitive workloads. You also need to make sure that your EC2 has Instance Connect software installed. Finally, Instance Connect solution we discussed in this video only works for Linux, not Windows. So, as an alternative, you may consider using AWS Session Manager, which does not require you to open inbound port 22, and it still uses IAM credentials to authenticate. You can check out the Connecting to EC2 using Session Manager video to learn more about this option. Well, I hope you found this video useful. Thanks for watching and keep on building.